This is a video on using Euler's method to find an approximate solution to a differential equation. The question states, use Euler's method with step size h equals 0.5 to approximate y of 2 when y prime is equal to 2x minus y and y of 0 equals 4. The idea of Euler's method is to start out with the initial value, which is 0, 4, and then plug that number into the slope. Of course, if we plug in 0 and 4, we get 2 times 0 minus 4, or just negative 4. So what we're going to do is we're going to take that point and the slope, and we're going to go down along the line with that slope until we've moved 0.5 units along the x-axis. And we're going to arrive at a new point. Then we're going to take that new point, we're going to plug that into the derivative equation. That'll give us a new slope. And then we're going to travel from that new point along the line with our new slope until we've moved an x distance of 0.5. And then we're going to continue on, plug in, get our new derivative, new slope, move along until we moved an x distance of 0.5, and keep going until we finally moved to x equals 2, and then we'll arrive at our value for y. So the formula for that is that to get to our new y value, we're going to take our old y value and add our h, our amount we're moving along the x direction, times the slope, or the derivative. So our h is 0.5, so I plug that in. I plug in 0.5, and I'm going to draw a little table, and notice that we're given that y of 0 equals 4. So if x is 0, y is 4, and then I plug 0, 4 into the y prime equation, and I get 2 times 0 is 0, minus 4 is negative 4. And now let's find our new point. To find our new point, I plug in. I have my original y plus our step size 0.5 times our slope negative 4, and I get 2. So now I'm going to plug in 0.5 and 2 into our slope equation. And when I do that, I get 2 times a half is 1, minus 2 is negative 1, and that's our y prime, or our slope, for our next line segment. So then we keep going. Let's find our next value of y. We plug in 0.5, 2, and our slope is negative 1, and that gives us our next value of 1.5 for y. Then we plug in 1 and 1.5 into our slope equation and get y prime is equal to 0.5. So we do it again. And now I'm going to plug in 1, 1.5, and 0.5 into y sub n minus 1 plus 0.5 times y prime. And what I got was 1.75. And that gives us our next y. So we plug in 1.5 and 1.75, and that gives us our new slope, 1.25. And we're almost done. Now we want to find, remember our goal was to find y of 2, and we're now on x equals 2, so we can plug in 1.75 for y and 1.25 for y prime, and what I get is 2.375, and that's the value of y when x is equal to 2. So that's my approximate solution to this differential equation. Y of 2 is approximately equal to 2.375, and I'm done with the problem.